Okay, number 11, center mass problem, uniform thickness and density. So that means that the mass of the various parts is going to be proportional to the area. So we'll work with areas here. And we're given the center of mass here. So x equals 3, y equals 4.5. So a couple things to note here. The value x equals 3 implies that we're given a coordinate system. Alright, so we're have to work with this coordinate system. And x equals 3, y equals 4.5 is somewhere about right in there. Okay? So, same idea as what we've worked before, it's just we're given a little bit different information. We know the balance point. We want to actually determine the location of this void or this hole. But we use the exact same process. We want to determine D, the center of the hole, and all dimensions are in centimeters. So we'll go ahead and write our equation for the y center of mass because D is in the y direction. Alright, so in general it's y bar is equal to the sum of all the individual parts of the mass times the y values over the sum of the total mass. Okay, again we'll work in areas because it's proportional to mass in this case, and we'll need to figure out how to break this thing down. It should be pretty obvious that you're going to break it down into a single large rectangle, okay, minus this hole. Okay, so let's see, this is 6 and 10, so a 6 by 10 rectangle minus the 2 inch or 2 centimeter radius hole. Alright, so we're given our y bar, so we know that value, 4.5. Okay, the mass of the larger one is just its area, 6 times 10, and its location of its center mass is halfway up in the y direction, so that's 5. Okay, and then we're subtracting out the whole. Its mass or area is the area of a circle, pi r squared, so pi times 2 squared is the area. Okay, the location of its center mass with respect to the vertical direction with respect to the x-axis is actually the value we're looking for. Okay, and then we just repeat these areas that we had up here, 6 times 10 minus pi r squared. Okay, since this is a void or a hole, we need to make sure we subtract the values on top and bottom. Okay, so I will use Mr. Solver to solve for D here. Probably overkill, but I'll do it anyway. Minus 4.5 plus, let's clear this out, minus 4.5 plus quantity 6 times 10 minus pi r squared. Alright, so that's this quantity in the bottom. Why did I do that? I want the quantity in top. Okay, so 6 times 10 times pi times 2 squared. 6 times 10, excuse me, I'll get it in mode here in a second, times 5 minus pi times 2 times squared, pi 2 squared, times our D or our X value. So that's that quantity divided by 6 times 10 minus pi r squared. Alright, getting going here. We'll make an initial guess of 5. Okay. Because we know that's somewhere close, and the final answer is 6.887 or 6.89 in units of centimeters. Okay, again, make sure if you're given a coordinate system to use it, and make sure to account for negative areas with negative signs here and here. And just a quick reality check, we know that if the hole wasn't there, the center mass would be at 5. We've taken some mass out of the top, so the center mass would actually so the mass of the whole thing is at 4.5, which is slightly below 5. It's because we took the area up above 5 out as far as the hole. So we would expect that value, both as drawn and just thinking through it, to be somewhere in that 6-7 range.